All right, if everyone can kind of, all right, sweet. We're trying to keep it pretty informal still, but if everyone can hear us, yeah, so we have a pretty interesting panel coming up here. This is Alex Stokes. Many people probably know him. He's a prominent researcher in the Ethereum ecosystem, and there are a bunch of other people here who are going to be speaking all about Ethereum and protocol complexity. So if you're interested in that, tune in real quick. That'll be happening just after this. But I just wanted to talk about, since SheFi got cut off, I cut them off in the last presentation about an hour ago. They are accepting donations. They have an ENS name, shefi.eth. It's just how it sounds phonetically, shefi.eth. And also Crypto Chicks. This was a different lady who was going to be speaking shortly after Maggie. And Crypto Chicks is very similar. It's also like a women-led organization, teaches women all about protocol, and it's an educational platform. So cryptochicks.ca. I don't know if they have an ENS name, but for now I'm going to turn it over to Alex and this wonderful panel to talk all about protocol complexity for Ethereum. Yep, we're all really excited. So thank you for being here. And also, feel free to have conversations outside and keep things relatively informal. Cool.
Hello, everyone. Happy 420. Can we do a mic check really fast, just so everyone knows that their mics work?
Test.
Test. Okay, seems good. Okay, hey everyone. So we have a dynamite collection of people here. They all do very impressive things on the software you run to keep the network running. We have a good mix of client representation, both on the execution layer and consensus layer. Before we jump in, I just want to say thanks to ChainSafe. Perhaps we'll have a round of applause just for hosting the event and everything. So we essentially, this can go wherever you guys want to take it. Like a suggestion is discussion of protocol complexity, both in the short term, medium term, long term, whatever you feel like speaking to. It's been a topic in the discourse lately, so perhaps given everyone's unique position here in terms of implementing clients and things, you probably have some unique insights into the protocol, where it's heading, where you want it to head, where you wish it would head, these sorts of things. So to get started, how about we all give an intro, just your name, your team, maybe a fun fact about your client, but don't be mean. I'm Alex Stokes. I'm a researcher at the EF.
I'm Etan. I'm working on Nimbus for status.
My name is Matt Nelson. I'm a PM on the Besu team. Fun fact, I suppose, is that we're probably the only one here that works on private networks, but that's kind of a sad thing these days.
Oh. Hi, I'm Adrian Sutton, and I work on Teku. I don't have a fun fact about Teku.
Something about memory consumption.
Yeah. Hi, I'm Zsolt Felföldi. I'm from the Go Ethereum team, and I'm responsible for Alias and the Get Light client. And the fun fact about it is it's sometimes usable and it's sometimes not.
We are being mean.
I'm Andrew from Erigon team, and fun fact is that we also have Erigon is in Go, and we have C++ and Rust implementations in the works of the architecture.
Hi, my name's Paul. I work on Lighthouse. Fun fact is we're going to do a rug pull in 3 months. No. Actual
you
fun
heard
fact
it here
is
first.
that it's called Lighthouse because it was the beacon chain and it's written in Rust, and we thought that a lighthouse would be a pretty rusty beacon to the proximity to salt water, so that's where the name came from.
Hello, my name is Cayman. I work on ChainSafe's Lodestar. I guess a fun fact about our client is it's the only client written in a scripting language, so we're masochists. Yeah.
Hi, I'm Giulio. I work on the Erigon team, and I am responsible for the merge on Erigon.
Okay, thank you all. So Didn't really prepare, so I'm just going to kind of ad-lib it. Protocol complexity. So, does anyone have any hot takes just to jump in here? Like,
I
okay,
can
that was
propose
fast.
I was going to say,
I can propose a
it's
topic.
always fun to talk about whether the consensus layer specification should be optimized or not. It seems to make it very simple for the researchers to analyze the protocol when it's not optimized, which is definitely something to aim for. But it does mean that the implementations vary wildly from the specification, which means that we get consensus bugs. So I'm not saying either is better or not, but that's always fun to talk about, in my opinion.
Yeah, that's a really interesting one, actually. For most of the spec, I don't mind the fact that it's not optimized. We kind of wind up with something vaguely similar, and there's kind of almost tweaks around the edges. You can see how it maps. But fork choice terrifies me. The implementations that all clients use for fork choice is absolutely nothing like the specification, doesn't map in any way, and is terrifying.
And the specification, what that actually specifies, is turning out not to be not so great as well. So
yeah, that's a bit sad.
Okay, so that's on the consensus layer, and I suppose we're working on execution layer specs, but I guess the direct equivalent for now would be the yellow paper. I don't know, anyone have any feelings about the yellow paper and the execution layer? Does it help you implement a client? Do you even look at it? How do execution clients think about that process? I guess you just look at EIPs now, yeah?
Yeah, I was going to say. Oops, sorry. Well, that is the problem. There's too many, right?
Too many EIPs?
Yes.
Never.
I mean, there's a mix of challenges, but yes, a lot of EIPs, which is always great because they're improvement proposals, right? So we're improving, but
Possibly.
we got that big geth in the room, and we gotta improve against the standard, and they can improve from the perspective of being the kind of standard. So that's kind of my personal gripe, that we have to try to differentiate while at the same time working against a standard that is constantly evolving. And so how do you kind of find a niche and develop features when you are being thrown active research topics?
Yeah, I think I got this impression that there is a bit of a disconnect between ETH researchers and code devs. So how do we bridge this disconnect? It's not necessarily related to protocol complexity, but it's a challenge nevertheless.
Yeah, definitely. And then there's this like very historically developed and sometimes opaque process of like all core devs and what EIPs go where and how do we decide that, and yeah, it's a tricky problem.
I would say that it seems that the consensus layer doesn't have the same type of problems that the execution layer has, in that there's no kind of one implementation that has to be obeyed, and it's a lot more equal footing. I guess that's lessons learned, perhaps.
Yeah, I think that's really interesting. Fun fact, I used to work on Besu when it was prior to its launch, so I've actually done a clean room implementation of the Ethereum 1 execution layer. We couldn't look at Geth, it's GPL, and we were Apache licensed, which is a real challenge, and I can tell you the yellow paper is just worthless. That's my hot take for the night. Like, you can't implement a client from it. I don't see the point. You just can't use it. You kind of almost have to work through the EIPs from way back when, and I'm not quite sure how they got phase 0, like the very earliest milestone done. It was done before I joined the team, but that was just deep dark magic for working that out.
Yeah, so it's interesting because as we move towards the merge, I'm sure you guys have all heard of this. If not, you should go check it out. It's happening soon, TM. However, the question now is like, how do we, especially as we look beyond the merge and have these like features we want to add in Shanghai and things, the question's like, how do we go about this process? And then there's like almost meta question of like, how do we change the EIP process to incorporate changes at the consensus layer, the execution layer? There is work on like an executable spec so that we can deprecate the yellow paper. I don't know if anyone here has looked at the execution specs, if you like them. Yeah, well, maybe that's too pointed. Do you have, what do you think about them?
I think it's basically the consensus spec is itself a Python code, and there is like a unit test suite sort of that includes the entire spec, and then the tests run in the context of that spec. So like the tests reuse all of those spec functions. And I mean, personally, I have contributed to it like as part of this light client libp2p protocol, like the new one that will sort of replace optimistic sync for some implementations. And it was very easy to extend, actually. Like, you can just call the spec functions and like add your test to it, and like it can also be run in a generator mode that generates test cases, and then you implement it in your own implementation and optimize it, because like the optimizations are not part of the spec, and then you can run it against the test cases. So it's like saving a lot of time on the testing front.
I wanted to speak to maybe an optimistic point after the merge. I think that some of the EIPs being proposed that are adding new features may end up cutting some of the, I guess, complexity of maintaining a client. Things like the EIP 4.4s and maybe Verkle trees later, things that can kind of cut some of the technical debt that Ethereum has been living with. Maybe it will make it easier for new clients to come, or maybe make it easier for existing clients to be able to get off this death track of having to follow Geth.
Well, actually, now let me just speak on behalf of Geth. So, yeah, the problem exists, and we are also not super happy about having to run after the EIPs. And yeah, I'm not putting blame on the research guys. It's really great that research is being done, and obviously it's a different perspective. And yeah, they are usually enthusiastic about all the possibilities, and they see engineering problems as just engineering problems, as it's infamously said many times. But yeah, so it's just the thing that we have enough capacity to make everything work reliably. Actually, things basically progress as fast as the main client implementations can make it work reliably. And we are also talking about what should we do with the specs, how should we yeah, this is true. Basically, we have the yellow paper and we have the EIPs, and this is the spec. Yellow paper plus EIPs, and this is, after sometimes it will be just unbearable. And yeah, so we have at least we also have a lot of testing suite. So at least it's not just some Python code. We have lots of fuzzers and everything. So once the client is implemented, you can test it against the others. But to getting there, it's true. It's a problem, and we also don't want it that way.
Yeah, I just in general, I think that making simplifications to the protocol is very tough, because you have a lot of contracts that you're not supposed to break. There are some occasional exceptions, like for instance, I'm a big advocate of the self-destruct deactivation, and the reason why we are even thinking about it, because there are only few contracts that use this feature. And like from Erigon's point of view, it introduces a lot of complexity, because we have an entirely new concept to deal with, the case when you can resurrect a contract. So self-destruct would be a big thing. Also, another possibility is that when you find a new generalization, that like all your kind of corner cases, they are suddenly become only just specific cases of a more general abstraction, but that's rare. That this can happen once in a while, but well, then you're lucky.
Yeah, definitely. So relevant to this is the topic of protocol ossification. So, different blockchains approach this differently. For example, Bitcoin will probably never have a hard fork ever again. Maybe soft forks here and there. Still waiting for the OpStark verify. However, on Ethereum, I think people would say we're still in like a evolutionary phase where, we can have breaking changes sometimes. And yeah, I don't know. I wonder if you guys have any insight as client devs into this like notion of ossification. Like, is it something we should strive for? Is like Ethereum this like locus of innovation and it will always change? How do we think about this?
I think that in order to achieve something like that, you need to have more client diversification. So the thing is this. So for example, with bill as signature precompiled, Go Ethereum is not implementing them for now. Why? Because they don't have the cryptographer. If something goes bad, it goes bad. If they don't understand it, they don't trust it, how can you even fix it if it breaks? You can just fix it. You're stuck with something that doesn't work and breaks everything.
And you're concerned. So your point is that you think the guests should implement the BLS precompiles and get a cryptographer?
No, because if they don't have him for long enough, how can they trust him? Like they don't have the expertise to do it.
Yeah.
If something breaks, it breaks. If it's not competent enough, then it's your problem at the end.
There is an interesting argument about, so we have the BLST library, which is BLAST, which is the kind of fancy assembly implementation of cryptography. And I think that a lot of all of the consensus clients have standardized around that. And I think I would expect guests to be able to do a similar thing with some degree of safety. And I'm not sure, Ben Edgington made a point that he doesn't really find value in diversity of cryptography libraries to be particularly useful, and I hadn't considered that before, and I'm also with it. So I guess for Geth's case, I'd be tempted for them to just say, you know what, they go with BLST, and all the other teams that do have cryptographers now, they're kind of your cryptographers as well.
Yeah, to be clear, the precompiles are implemented. They're just not shipped in the production client.
Yeah.
Are they on BLST?
No, I don't believe so. I don't.
They're not precompiled yet.
I think it's a different library, but either way, we were talking about this the other day, and so it's a good point. It's like, you know, do you try and have like, you know, this role is probably like an applied cryptographer. Do you try to have an applied cryptographer per client team? Doesn't seem to scale. Do you have like, you know, a team of, you know, one team that is like responsible across all clients? Like, are you guys comfortable with randos like trying to fix your code? Like, I don't know.
I mean, my role as well is to manage the people on the Lighthouse team, and I know that getting a cryptographer on for a particular role is very concerning, because what would they do once BLST is running well, and also where would I find a cryptographer, and where would I find a cryptographer that is willing to, you know, work on practical problems, not just, you know, being in an academic basement solving kind of weird things. So it's a challenging problem.
CKVM.
I think that we should also prioritize scalability. Well, I still kind of would like to have some scalability on L1, and if it's only L2, still like, because that's, to my mind, we can introduce complexity to actually solve the big issues. And to my mind, the biggest issue is the scalability and like the gas cost. So for that, we can add some complexity. For smaller things, maybe not so much.
I think I'll go out on a limb and say that if Ethereum ossifies, it dies. What's the point?
That's a hot take.
Yeah. I'm it's late. No, but seriously, Ethereum has always had this vision of change and a roadmap of a load of stuff. And we've gotten through a heap of that stuff, and the roadmap is dramatically longer than it used to be. Like, we are not making any kind of inroad into the amount of stuff we want to get done, because we keep finding new stuff to put on the end. And it's powerful and it's important. And to look at that and go, no, we're gonna cut that off there, and no other new use case will ever be useful or worth doing, it seems kind of crazy.
Which is fair, but again, I think this argument is usually more like follows, which is, okay, you freeze L1, so to speak, push innovation to L2. There's some conversation over the past couple of days about like having experimental rollups and maybe backporting those features into L1 once they've been proved useful in L2.
Yeah, I think there's some really useful and important techniques we can use like that to help us be confident in what we're doing, so we can be conservative but still move forward. it's not a case of stop changing things. That's really poor engineering practice to say that we will just not touch that and it'll be fine forever. That's not how we write software. We've never seen that work anywhere. It is actually, we refactor relentlessly. We keep things current and keep improving things, and that's how you get good software. And we should apply that to Ethereum just as much.
Yeah, we also thought, like, let's just give him like 64 EVMs and then we'll just be sweet from there on. And then we were like, oh no, actually someone invented new cryptography that's roll-ups.
1024 original.
Yeah, 1024 EVMs, and that's all they'll ever need, right? And then someone invented roll-ups, and we're like, no, actually, let's do that. And now we're going to be like, well, after we implement roll-ups, then there'll be nothing else left to do. And then it's going to be, 3 or 4 years later, and someone's invented something else, and then we'll need to add that in. And it's not. I think we're kidding ourselves if we can think that we can see so far into the future that we can ossify. Now we can't. We have to keep staying. We have to keep jumping around.
And I think to your earlier point that we should enforce a level of backward compatibility is also kind of a short-sighted view. And Ethereum might be the only platform in which that is the case. And we constantly see innovation where you force developers to update to be on my platform, et cetera, right? So to Adrian's point, the ossification, who knows what's going to be valuable in 5 years? And at the same time, dApps can be updated, and all these things can be changed, and they're not going to lose. They're incentivized to do that, right? So as a protocol team, we shouldn't absorb that complexity. We should absorb what is valuable for the spec, right?
Yeah, the other day we were talking about merge timelines, and someone said, oh, what if the DeFi apps don't have enough time to migrate? And I remember Marius from Geth just kicked back in his chair and he goes, fuck him. I was like, yeah, I like that.
So here's an interesting topic. How do we feel? Well, okay. So I wanna dig into this idea of tech debt, right? So I know that all of you are very, very, very busy. You're some of the busiest people in the space, and part of that work, right, is saying, okay, there is so much happening so quickly. It's there's this tension between, okay, we need to ship the next hard fork versus let's refactor sync so it's not a tire fire. So yeah, I don't know. How do we see the trade-off there? Do we feel comfortable with how things are? Do you feel like you have enough time to refactor your code base and make it more maintainable in the long run? Do you think we're pushing features too quickly?
We haven't even gone through the merge, and we're talking about Shanghai. So.
Well, we can't do
you
nothing,
can't,
right?
like you said, ossification is bad.
You have to parallelize.
I think that tests are super important. We have a nice kind of relatively comprehensive test suite pre-merge, and for merge we have this tests in Hive, which are still maybe not as well established. So I think we need to invest a lot of time and effort into test suites. That would help us to move at a reasonable pace.
I feel like the consensus clients have had it easy. I mean, at least for our team, we've had not plenty of time, but time to be refactoring and pushing the latest features for the merge, and still, I mean, we're refactoring various libraries multiple times after learning new things. And
yes, but you're about to hit mainnet. You'll get roped into the process.
All right.
I think it's just one of those things that you've got to learn to do is refactor as you're adding stuff. It can't be we stop adding features and go back and refactor. Again, we've constantly seen that fails as a software strategy. Software development is about refactoring as you're going, and as you're doing things, you make them a bit better. And often, the best refactorings and the best cleaning up you can do is because you've made progress. So, Etan and I were talking before about, the light client sync. And that's only possible because of the feature we put in Altair. And Altair was really meant to be a rehearsal fork that didn't add any features. We kind of crammed that one in. And it's worked out well, right? So a lot of the time, adding new stuff is the opportunity to then go back and say, we can do this better, and we're touching this component, so let's make it better, and so on.
Yes, I can totally confirm that. All the new features we add to get, they usually force us to do refactorings. But yeah, I can say that. So I wouldn't say that we are piling up tech debt in the code. So we usually don't let ourselves be pushed too fast or anything. It's just, yeah, the complexity is growing, and sometimes it feels a bit scary that maybe at one point it will just the complexity will become uncontrollable, because I don't know, now there are like data blobs, and then okay, maybe the incentive system has to be changed. Okay, now the 2-dimensional pricing should be 4-dimensional. Oh, maybe why not 40-dimensional? I was there, yeah, I was talking with Vitalik about this. So yeah, I'm also like, I love interesting ideas. I can also come up with shit like this, but sorry, yeah. So actually, with like a light client protocol and everything, I also sometimes go overboard with, okay, let's make it like really good, and prepare for like being in the future maybe very scalable, and maybe sometimes it's just. Yeah, so thing is that we with like the core protocol, sometimes it just feels scary that there are the moving parts are just piling up. But yeah, the code actually usually gets cleaned up, at least when we do all these changes and we do the necessary refactoring. So yeah, that's how it works.
I think a lot of the complexity also, like of this tech debt, also comes intrinsically from cryptographic advancements. Like this switch to statelessness, it will require a lot of state rewriting, and like, I mean, of course, you could like just take Ethereum offline for a day while everything gets rewritten, but it's like, yeah, I mean, those advancements are not really something you can sort of plan or do incrementally. It's like, hey, there is new crypto that is better, that allows a lot more efficient storage, so it sort of has to be done. And then the tech debt that piled up over all the years, like, you cannot just get rid of that like through careful planning.
Yeah, and it's one thing to update the database to Verkle. Yeah, that's also not very easy. But then convert an existing database, like convert it online or stop, I don't know. So yeah, we have discussed many options about this. But when people come up with new ideas and new ideas seem to be workable, that's one thing. And we think about all the implications, like how will we do a live heart transplant on the network? That's usually way more complicated.
Yeah, I would say if the question is, are we moving the protocol so quickly that the implementations are going to get messy and unmaintainable, I would say that it's, personally I would think that it's probably unlikely that the implementations are going to become unmaintainable. It's more likely that we're going to burn our developers out and then end up without anyone who understands the code base. So I think the important question in terms of how fast is the protocol moving is the protocol moving so fast that we can't maintain our developers and we're going to burn them out? Because I think that the people we have on Ethereum are so talented and so invested in their code bases that, you know, they'll burn themselves out before they let spaghetti code in. So I would say that's the concern. And to be honest, is the protocol moving so quick that it's burning developers out? I definitely wouldn't say it's not moving so quick that it's burning its developers out. It hasn't burned its developers out so quickly, but I know personally, there's signs of burnout on me. So I think it's moving any quicker wouldn't be great on that front.
I think that's actually something the consensus devs need to learn from the execution devs as well. If you listen to an all-core devs call, the core devs are saying no a lot. And there's a lot of discussion and a lot of pushback and demanding justification for things. And that's hard-won experience. And then you listen to a consensus dev call and it's like, should we do this? I guess we're doing that then. So we kind of need to learn to speak up, and I think that is one of the responsibilities of being a client developer, is saying, no, the timeline you're setting is not reasonable. We will not be ready for that. We're not supporting it. And being okay with that, and then you're going to cop a lot of heat. And just accepting that as you know, you're under pressure to.
boundaries.
Yeah. It's tough.
Okay, what else?
I think we're all too burnt out, right?
I don't know. Are there audience questions that could be interesting? Yeah.
Can the yellow paper be reformed or should it be culled?
Burn it.
Yeah. What?
Reformed in what way?
Making it less map heavy, having more explanations, diagrams even, that could be a change.
Well, it would be great, but I kind of have been the maintainer of the yellow paper for Berlin and a couple of releases before that. It just it takes a lot of time, and I totally agree that right now it's not especially well written, but money we need somebody who, because it's a full-time job to kind of rewrite it in a good way. It will take a few months, like of a fairly sophisticated person. So, yeah, that would be great if you find the right person.
Yeah. I think one of the big challenges is that it's kind of a separate thing. We do EIPs to update the process, and then some poor sucker, which turns out to be you, has to go and update the yellow paper, and it's a hard job.
Yes, it is. I also think there is a lot of value in having a formal description of the whole of Ethereum. I am afraid, because that's maintaining the yellow paper is not my main job. I've been doing it as a hobby. I am afraid that I won't have the capacity to update it for the merge. So, yeah, we probably, if there is a volunteer who wants to update the yellow paper for the merge, that would be fantastic.
One challenge is also in Ethereum, the individual concepts, I mean, they are sort of like silos. You can understand SSC serialization, for example, without understanding anything about the rest, and it takes maybe a month or two until you are really in depth and can write something that creates a proof in an efficient way, like a multi-proof or something. And this leads to a lot of individuals being very knowledgeable, in depth about very specific details of the protocol. And the knowledge transfer is so inefficient because it takes so long to sort of get the knowledge. It's not spreading that quickly between team members even inside the same company. So yeah, I mean, getting an entire book out of Ethereum that sort of explains everything to a degree that you can understand it, it's probably an entire team's effort, I guess.
I'm an expert in the abuse of SSZ offsets, and I will explain it to anyone that asks.
Sure. No, but I mean, it's just it's an additional challenge to create such a documentation because there is no individual that knows every single detail of everything.
Maybe that's the way Ethereum's going as well. I remember I was reading, I don't know if this is appropriate, but reading Peter's tweets from Geth, and he was I got the impression he was expressing that he, after the merge, he doesn't have a grip across the whole protocol anymore, and that if it breaks, that he doesn't have the ability, the knowledge to fix everything. And maybe that's the way it's going. I guess if your laptop breaks, there's no one person that knows exactly where it broke, but it's still very useful. So maybe Ethereum turning into this thing where no one knows the whole thing is necessary, and it's okay.
Yeah, I love Peter, but we can't depend on him fixing Ethereum forever. We need to move beyond that and not have him even feel like he needs to.
Sure, but the point that it would be beneficial if one person could at least theoretically understand all the important parts of the protocol. So yeah, definitely that's another question, that it shouldn't be really one person.
Right, so that's another interesting question though, is like, are there, like, what formats do we have for this knowledge transfer, like, you know, amongst core devs? Like, should we work to have like more forums for this sort of thing? It sounds like it's important. We chat some on the various like EL and CL calls, but, and there's like informal things, right? But it's like, I don't know, should we as developers strive to like push for something?
Create songs and pass them down through our people, I think.
We could.
Will you create them?
Any other audience questions? Okay, Mark?
Yeah, like to what extent the way that I've looked at this, it seems like an intractable problem. Like it's like a part of the blockchain developer condition that you can't, unless you take the Bitcoin approach of like our base layer is gonna do like payments. That's it. Like you can't have a lot of features like we have and just not have complexity. And so I guess if that's the case, does this become like, if this is possible, does this seem like the right group to do it? If what we're even attempting is even possible, like
I don't know who else is going to.
Like the question is like, do you think the complexity is inevitable? You can't avoid it, and
the question is, do you think the complexity is inevitable, like you can't avoid it if you're going to have a smart contract layer 1 that's proof of stake and has all the other features, and 2, if it's unavoidable, then do you think we can still do it?
It must be done. It will happen. But yeah, I guess the question is like, yeah, how, which is really, I think, the whole point of this panel is like answering this question, like how complex is too complex? Is everyone here comfortable
That's a
with?
question that engineers and the researchers have different ideas about.
Yeah, I think it's really important that we strive to make the protocol as simple as possible. And you know, maybe we do say no to a bunch of features because they just add too much complexity for what they're worth. So that's kind of step one. But I think also we've learned that we can build really big complex systems by defining boundaries within them and being okay with, I understand this bit and that's my job and I don't understand that. And you know, this conference has been really good for me in seeing how much I've done that, because people keep trying to talk to me about things above the EVM level, like apps and using the chain, and I'm like, what? Because I came into Ethereum, like I knew nothing before I joined Consensus. I wasn't a blockchain user, developer, or fanatic before I joined Consensus. I've learnt everything here on the job. And so I know protocol development. And like I'm not a complete idiot about what's above it, but it's not my role, and I can't write Solidity to save myself, but I can write EVM, you know, assembly.
So actually, I think that the way currently execution layer and consensus layer are separated, that's, I think, might be a good example of handling complexity. So it's one thing that, okay, how many moving parts we have, but I think a more important question is, yeah, so can we somehow divide the responsibility of understanding it, and maybe after like the merge really works out, we can start thinking along similar lines with other like areas of the protocol.
I think this goes back to the concept of compartmentalized complexity, right? Like where does your boundary end, and how, to Adrian's point, how do we push more of that kind of up the stack? Because, you know, protocol complexity introduces a whole number of challenges that, you know, are a little bit larger than what could happen if you write bad Solidity code. So I think that, you know, pushing it up the stack is not necessarily something we should be afraid of, and it's, you know, keeping the protocol simple and keeping our approaches simple, and also compartmentalizing those areas into these different modules like we have at the EL and CL.
So basically, we sometimes have to kind of refactor the specs also.
That's fair. You know, sometimes things come back down, right? But Yeah.
Yeah, so from this aspect, yeah, it is a problem that the specs are a yellow paper plus a bunch of EIPs, but maybe over time, well, maybe at one point we have to slow down a little bit with adding new features and spend some time making it understandable. Maybe we are going to be able to do it. I don't know. On the other hand, it is understandable that there's a push for delivering something relatively kind of scalable in a reasonable time frame. Also, it's the same thing with also the whole merge that we could spend another, I don't know how many years to make it even more safe and even more provable and reasonable and whatever, but it's just, yeah. So I'm not saying that we have serious problems and we should operate really differently. It's just, we are facing a lot of new challenges and we should constantly think about how to approach them. So, yeah.
So I think trying to separate concerns is important and helps, and we try to modularize Erigon a little bit, and it would also should have performance implications. So that's important, and we should keep doing it. Also, I think in terms of managing complexity, after gaining experience, we could differentiate accidental complexity, some quirks that are there for historical reasons, from fundamental complexity. And the accidental complexity we can probably somehow try to simplify, but fundamental complexity, if we understand that is there for a good reason, then, well, that's life.
Well, I guess I kept hearing compartmentalization. Yeah. Well, or maybe you could just riff on this, but you guys kept saying compartmentalization is a solution to this, but then the problem is you have emergent phenomenon where the properties of the system all put together are different than the properties of any of the components in isolation. So how do you deal with that?
I think you deal with that like you do with any other software project. That's what software engineering is being able to compartmentalize well and build bigger things out of pieces and have them work without getting those strange emergent behaviors, because you've got clear boundaries and well-defined things. You know, the amount of software in a rocket or an airplane or things is absolutely massive. The code bases we work with are actually pretty small. There is quite an entertaining amount of complexity in there in terms of what you understand for what they do. But we have faced these challenges in software development all over the place, and we just need to apply the good lessons that we've had from the 70s and kind of skip some of the bad ideas we had in the middle, and just do it right. It is hard. It's not like, that's not a silver bullet. It's a hard thing that it requires constant discipline and learning, but it's entirely doable.
Does someone else have a question?
Does anyone have any thoughts on Vitalik's article? Vitalik wrote two cool articles, one quite old where he talks 3 meanings of decentralization, and one of those 3 was logical decentralization or architectural decentralization, so say it's consensus layer, execution layer, but then I think Erigon on the idea of database, and then likewise would you have a precompile layer maybe, or EVM APIs and so forth. So that's one aspect, logical decentralization, whether anyone has thoughts on whether that is a virtue to actually strive for, or whether it's merely pragmatically worth having, but maybe not actually virtuous for, say, legibility. And then the other question is, does anyone have any commentary on Vitalik's article, encapsulated versus systematic complexity, where, say, he compares about the idea of black boxing things. So Greg Colvin has some interviews where he mentions that many people treat the EVM as a black box, and he personally has an inverted view where the EVM is the thing that he deeply understands and everything else is a black box to him. Whether the question is, should we strive to avoid, or any commentary on the Vitalik question of, should we try to encapsulate complexity and modularize as much as we can and have a black box approach? Or should we as Andrew was saying, perhaps really just avoid accidental complexity. But if there is systematic or emergent complexity, that we just sort of like have to address that fundamentally, I suppose. Maybe that was a bit too vague, but vague responses would also be appreciated.
Okay, so if a certain part of the software fits into a black box and we can have a simple interface and it doesn't interact in many weird ways with the other components, then yeah, sure, of course we should do it. That's how software development works. That's just good technique. But thing is with all these new EIPs and breaking existing invariants, sometimes and actually quite often, things that previously didn't depend on each other, didn't have to interact with each other, start to interact with each other. We have to pull in new wires between the layers, and suddenly we have a black box and 25 wires coming out of it, and then it's not really a good black box anymore. So yeah, of course, if possible, then sure, but then it's a lot of refactoring to make it easy to understand again after adding a new feature that changed basically everything. So, yeah.
Sorry, I have an example of how like different EIPs may interact with each other. For example, the Velcro tree, which is like in general is a good idea, probably, but what I'm worried about is code chunking, and maybe there is an adequate solution, but my worry about code chunking that it leaks a particular commitment scheme, which is the Velcro tree, into EVM execution, because now like EVM should be aware what code chunk I'm executing. That's one bit, and it also like kind of potentially, maybe not, maybe yes, interferes with EOF sections. Like, what if do you align EOF sections with code chunks? Not an open question. And it also leaks into how you organize your data structures at the fundamental level, which might be a good thing, but
Yeah, I just wanted to ask that very often it's not even new features and the IPs that make it necessary to just reach through layers, but simply optimizations. So it's just when it works, then okay, can we increase the gas limit? Yeah, everyone wants to increase the gas limit. And then just because, okay, it could be optimized if this part just knows about what that part does, it can exponentially blow up all these interconnections between layers. So yeah, that's another thing.
Hard trade-offs. Like this is what it comes down to. You can have this feature at this cost. Is it worth it? And that means that we need to say no to some things, and that might mean pushing them to layer 2. It might mean, no, you just can't do that.
Yeah, so of course we are always pushing back the request to increase the gas limit, obviously.
Yeah, you guys are good at it.
Okay, one more audience question if there is one. Otherwise, I'm going to declare that we're done. Yeah?
Maybe it's a good closing question. I was wondering, with all this experience building Ethereum clients, sitting on the stage, if we were to, if you had the chance to build Ethereum from scratch again, how would you reduce complexity? And or to rephrase it, what's the most annoying feature of Ethereum that you would potentially remove or not even want to implement again?
Merkle trie structure.
maybe it's, if it's a closing question, if I may, maybe each of you just comment on this.
So I guess I'm starting. So at Status we have like a Nimbus consensus layer and a Nimbus execution layer. Like the execution layer is still in development, so it's relatively unknown. But I think one thing that would be nice is like to merge those two, just to get rid of this execution API between them and like all this REST stuff. That's not really necessary. It's like just unnecessary, like to have both of these components running on the same system and talking through these network protocols with each other.
I guess that's true if you're a team that's willing to take on the responsibility of both, but it doesn't necessarily work towards compartmentalization.
Yeah, so it might also be a good thing to have this good separation of these. Maybe we could do it like a better way if we were building it from scratch. But yeah, it's not necessarily all bad, I think.
He took my answer, so I was gonna say, literally, yeah. The introduction of two clients is good in some ways and is more complex in others. If we could have started from proof of stake, we could avoid complexity there. So I guess proof of work could be my answer. But I'm younger than all these folks, so I'm worried about where the planet's going to go in 10 years.
Hey, man, I implemented proof of stake.
3 years of ProgPal and then the merge.
I think the main one for me is storing the state. Like, I love working on the consensus chain where state is like 50 meg, and so much stuff works so much better and more easily because of that. If we could have started with statelessness or just state rent or any of the ideas we've had that didn't work because of backwards compatibility and those kind of logistics, life would be so much easier to have this nice small state that just stayed contained.
Yeah, we should have started with a lot more complexity than we did. If we have too little complexity, that's a problem, yeah.
That's fair, yeah.
Yeah, sometimes it is actually, yeah. So sometimes that also happens. But yeah, I will just repeat myself. The thing I hate the most is this hexaread try structure that doesn't give any information about the size of the subtrees, and yeah. But we could also bring other examples. Yeah.
Account resurrection with self-destruct plus create 2.
I would say LMD Ghost and FFG fork choice, gluing them together. It seemed good at the time, but now we're down this track. I think we could have done better.
Maybe differing like standards between consensus and execution, like encoding, networking schemes, a lot of kind of code duplication in weird different ways.
I thought the aim of ETH2 was that if there was anything we could change, we should. Like that seems coming from Besu to Teku for me, it's like, oh, that's not the same either. Oh, none of my knowledge is useful here.
But if we restarted, we could just do it the good way, the right way.
Yeah.
I guess I will go for not having self-destruct, actually. Yeah. Yes.
Erigon really doesn't like self-destruct, does it?
We don't. We have a problem with incarnation. We invented incarnation, but they're very bad, so we have to deal with that. It's really a pain.
Okay, I think that's it. Thank you, everyone on the stage. How about we have a round of applause for everyone? Yeah, thank you. Is Josh here? No?
No, that's it. We're going to turn the music back up and party.